Hello everyone, welcome once again to another Power BI related tutorial on our channel Color Stack by Slidescope. In this part we are learning about creating this simple bank marketing performance dashboard. In this dashboard you can see we have different type of charts here which are representing the effect of different variables on the outcome, and the outcome is whether term deposit is yes or no. So when you will use yes, you will see its effect on different charts, and when it is no, its effect on other charts. After marketing campaigns, whatever amount of people said yes or no to term deposit, yes or no, so we have to find out which variables will help us in predicting that particular outcome and which variables will not be helpful. So after doing this exploratory analysis, we will be able to create machine learning models. So this is the first part where we are learning all of this, and step by step we will explain you the data set, how to download it, and how to create this type of chart. So let's get started and learn how to create this. So to begin analysis, first let's understand the bank marketing data set. This is the data set. You can see some fields here: age, job, marital, education, etc. This particular data set is available on the uci.edu website as a bank marketing data set, and data set is related with direct marketing campaigns, that is phone calls of a Portuguese bank institution. The classification goal is to predict if the client will subscribe a term deposit, which is variable y. Okay, and this data set is also available. More information about this is also available on Kaggle. And data set is related to direct marketing campaigns, and marketing campaigns were based on phone calls. Often more than one contact with the same client was required in order to access if the product, that is bank term deposit, would be yes or no, uh, not subscribed. Okay, here we have different type of examples. I will provide you source information, everything you can see from there. So in the data set we have age. Obviously this is age of person who was contacted, and we have the marital status, education, default, yes or no, we will understand this, balance in the bank, housing, yes or no, loan, yes or no, contact, day, month, and duration. Campaign 1, P days -1, previous, P outcome unknown, and Y. Now let's understand them. So balance is average yearly balance. Default is has credit in default. Loan is has personal loan. In contact, we have contact communication type. It is categorical, unknown, telephone, or cellular. So here we can see in contact. So I will simply create a table from this just to get all the filters. You will see. So in contact you have cellular, telephone, or unknown. Now in this slightly modified data set, day is last contact day of the month in numeric, month is last contact month of year categorical, and duration is last contact duration in seconds. So the duration that is given here is last contact duration in seconds. And other attributes are campaign, number of contacts performed during this particular campaign. So you can see some people were maybe contacted 63 times, it looks like. So number of contact performed during the campaign, and for this client numeric includes last contact. P days is number of days that passed by after the client was last contacted from previous campaign. Numeric -1 means client was not previously contacted. So P days has a negative value or all positive values, and these values simply represent number of days that passed by after the client was last contacted. We also have previous, number of contacts performed before this campaign and for this client. So for this we have previous, and we also have P outcome, outcome of the previous marketing campaign, unknown, other, failure, success. So if it was that contact was contacted previously, what was the outcome, failure, other, success, unknown. So you can see we have a lot of categorical variables, we have a lot of numerical variables also, some numerical variables, and on the basis of that we have to predict the outcome. And the outcome is basically nothing but the outcome is to predict y. Y is goal to predict if client will subscribe a term deposit, yes or no. So in simple terms, a term deposit is a type of saving account that involves depositing money for a fixed period of time at a fixed interest rate, and it's also known as fixed deposit over time deposit. So now this is a simple introduction of the data set of bank marketing data set. Now we will start performing some analysis. Now to analyze the bank marketing data set and find effect of different type of variables on our outcome, we will use Power BI. And in Power BI, first we will connect with dataset. So here, after connecting with the Excel file, we can see all the columns are mapped properly here, and we will simply load the data. So here in Power BI, first of all, we will add our text box, and in the text box we will simply write what we are doing here. And this is bank marketing exploratory data analysis. So you can play the video at 1.25 speed if you want to view it a little quicker than what I am explaining, because I am also doing stuff in between, so sometimes it may take some time. So now after writing this, what we can do, we can simply invert the color. So we will use a lighter color here, and in your text box, from here you can see your properties. In effects, you can go and you can select a background color. And what I will do, I will go to view, and in view I will probably select a different type of report view here. So now I have selected this, and here I will say I don't want a background. So this will give you something like this. And obviously you can get any other image here, but this is something that we can do. And here in effects we will just enable a shadow so that we can see where the text is ending. And in case of shadow also, we can select a light color. So, and based on our selection, now you can see the color palette has also changed. This is back marketing exploratory data analysis, and we have selected the simple background. Now our first variable is age, and it is a numerical variable. So we will see how age is distributed for different clients. Okay, you can see there are total of 45,211 rows here. Like the number of contacted people are this much. And before moving further, what I am going to do, I will just rename my output variable as term deposit. So if it is yes or no, on the basis of that, so this is simple term deposit. So it will be uploaded. Now, to see the distribution of age, we can use a stacked column chart here. In a stack column chart, we will just bring age, and so it will we will bring age on x-axis. So x on x-axis, and on y-axis, we will try to count number of rows. Okay. For every record that we have here, we don't have any index column. So we can go to transform data and create a index column. So here we will simply go to transform, and in transform we will go to add column and create an index column. And now we have an index column. What I can do, I will just redo this, but I will start the index from 1. So now every column has an index. Go to home tab, close and apply this. So every row has a unique value. So now when we will count these unique values, you can see how that data is distributed. And in the data set, you can see most of the people are within the age range of 30 to 35. Okay. So this is simple distribution of age that we have. Obviously, we may have customers in all age brackets. That's why number of bars here is, obviously there are too many bars. Okay. So what, how can we find out how many age bars are there? We can write count distinct and find out. But when you have some column like this in Power BI, you can create a group column. So you can click on these three dots here and create a new group column. And let's say our minimum value of customer age is 18 and maximum value is 95. So we will create age bins, group of age. So group will, so let's say we have these values between 18 to, let's say, 100. So let's say we are going to create six bins. So there will be six age groups, you know. So we will simply go with number of bins, and here we will say six age bins. Okay. On the basis of six age bins, every group's age size will be 12. So it will be something like 18 to 30, 30 to 42, 42 to 54, and so on. Obviously, it's pointed, so you can add that. So now this age group will be created, and this will show this icon. We will remove this and just introduce age bins here, and you will see six ages, and you can see from 18 to 30 we have sum of index is 173. So instead of sum of index, we have to use count of index. So this particular chart will show us how many customers do we have in each age group. So from 18 to 30 we have 7,000 customers. From let's say 30 to 42 we will have around 20,000, 21,000 customers. And then from 43 and so on, so we will have 12,000, and you can see the distribution, right? So this way, uh, it makes it easier for us to see and visualize the data. And we will simply go to our format visual part. So this is build visual, this is format visual. In format visual, we will go to general, and we will write distribution of age, distribution of age by term deposit. So you will wonder, we have not used any term deposit thing here. Before that, I'm just customizing it a little bit. And here I will simply enable, uh, I'll go to effect, and I will enable shadow here. I will go to title, and I like aligning it to center, making it bold, and choosing the color according to theme. But it is your choice, you can do anything else. And I also enable shadow and a visual border so that I can make it a little bit rounded shape. So I will apply 12 pixel. So this way I have distribution of age by term deposit. Now our term deposit is the output, and we want to see effect of all these individual columns on our term deposit, which is yes or no. So when you have a categorical column, you can simply click on it and bring your categorical column to the legend. So you have selected the visual. In your visual setting, you can bring it to legend. So we will bring term deposit to legend, and this will let us know, distribution of people who have actually said yes. So you can see term deposit yes is 1145, no is 5885, right? So the ratio of yes versus no in every age group can be seen here. Obviously, you can see because here we have more people, so then values are also more here. In case of 80, most people have said no, and in case of this age group, yes is 206 and no is 285. So here you can see people in this age bracket, the count is pretty much equal here. So this way you can understand in which age groups more people have said yes, in which age group they have said no. And you have your legend here, so you can click, and if you don't want legend, you can enable or disable that, or you can, you know, reposition your legend so that we can see the graphs properly. So this is something that you can do. Obviously, you can play with different type of settings to make it appear more, you know, we can say more highlighted. We can also go to background, and because we have some image, when we have some image in the background, we can try to increase the transparency a little bit to match with the background. This is one simple example that you can use. Next variable we have balance. So here we can see that different age groups do have some kind of effect on our outcome. So we will consider this for machine learning models. Now, in order to see whether balance has any effect, so what we can do, we can see average balance of those people who have a term deposit, or who have said yes to term deposit and who have said no to term deposit. So for that, let's select a pie chart, and here in pie chart also, I will click it, use format painter to apply the same style. In legend, I will bring term deposit, and in values, I will see average balance. Okay, so I will just bring average balance, not minimum, average balance. And you can see people who have term deposit, their average balance as per number of customers we have, their average balance is more, and people who don't have term deposit, their average balance is less. You can also see total deposit. Obviously, in terms of total, no is more. Okay, because there are more people with without the term deposit. So that's why in some you will see that, but on an average you can see, if we go customer by customer. So this is an important thing for us to consider. So our second variable balance also has effect on our outcome. Then we have campaign. So campaign is a number you can see. In campaign we have values from 1 to 63. So campaign makes number of contacts performed during this campaign and for this client. Okay. So it is numeric, includes last contact. So sometimes let's say I will arrange it in descending order. 63 times contacted, right? Number of contacts. Term deposit is still no. So it, so we want to see whether it has some effect on term deposit being yes or no. So I can also copy this and keep term deposit as legend, and instead of average of balance, we want to see average campaign number. So instead of sum, we will count distinct. So you can see on an average we have contacted, if 48 is the count of campaign, then it is no. Count of campaign is 22 in case of yes. Now we can also change it to a stacked column chart, and here we can see on x-axis we have term deposit, y-axis we have count of campaign. Okay, but what I'm going to do, I will use it in a better way. I will use groups also. So like for example, 1 to 2 contacts, what is output? 2 to 3 contacts, what is output? Something like that. So first I will use group here, and in group I will say, first it is giving a size of bins. Let's say we want total of, let's divide from 1 to 63 into 10 different bins. Okay, so when you will do that, you will, it will be bin size, but I also want to create some x number of bins. The average bin size is 6. So it is from 1 to 5 contacts, how many percentage of them are yes, how many of them are no. So what is the ratio of yes to no? Let's say I let's try to make the bin size of around 10. So we will use 6 bins here. You can do anything, like you can choose any matrix here, but I will simply drag it here, and instead of count I will use sum, right? And I just have to change axis. So here you can see, uh, it's interesting. You can see in case of 0, 10, 20, etc. And in legend, we will bring yes or no. Okay, term deposit yes or no. So now you can see most of the values of yes or no are here. Like obviously this is the biggest bin size because most people who are contacted are within this range. So what I will do, I will increase the bin size now because I can see there are many people. So to see its effect, I will increase number of bins to 10. Let's see. Now you can see data set is further divided. So I can see that in first bin size, yes, no is 37,000, yes is 5,000. Like most of the people when we are contacting, so in 0 to 6 times they are saying this. From 7 onwards, we can say we have a very small yes or maybe all no's here. Okay, and let's filter by yes. You can see only here we have yes. So we can now divide it further. So obviously very small bin size will be there, but this is simple approach. And let's say we are going to create 20 bins now. So in 20 bins, now we have more data, and let's see. So here you can see when we have 20 bins, so average bin size is 3.1. So in 0 to 3 contacts, 4,879 people have said yes. Here you can see 278 people have said yes after, we can say, 3 to 6 contact. So on the basis of this you can create a graph, and this is count of term deposit by campaign and term deposit. So we will simply title this in a proper way, and I am just going to call it campaign effectiveness. So campaign subscription rate by campaign attributes, and obviously we have enough space so we can keep the title in 2 lines. So this is one important chart. Now we can say that campaign has very little impact on the outcome, but still we are, that's why we are analyzing this. Then we have contact. Let's see. Yeah, so in contact we have cellular, telephone or unknown here. This is basically the contact communication type. So on the basis of contact communication type, we'll be interested in seeing the percentage of people who have said yes and number of people who have said no. So in order to see, you know, effect of type of contact on yes or no, we will simply copy this and not pie or donut chart here. So after copying this, first of all, I will get rid of everything. Obviously, in legend, I will keep term deposit, and here on x-axis, I will put contact, and on y-axis, I will put number of contacts, so count of index. And now, instead of sum of index, I will just use count. On the basis of different count of index, we can see in cellular, we have contacted most people by cellular contact type, and there no is 24,900 people, or almost 25,000 people have said no or are no here, and people with term deposit yes or outcome yes is 4,369. So we can see this particular contact type also has effect on, you know, the subscription rate, and we will simply change its title. So we will call something by some subscription rate by contact type. So by selecting each chart, by going into general and properties, I have made sure that every one of them has 300 size so that they look of equal width. Now we also have a column that is called day, and day here is given as a number like on which last day have we contacted the person. So as per the dataset description, last contact day of the month. Okay. So now what we can do, we can use a area chart here. Obviously, I'm going to simply copy the same style for now. In on x-axis, I will put day, and on y-axis, I will first put number of contacts that we have made. So obviously, in the number of marketing rows that we have, so we have index here. So on the basis of day, you can find out. This is sum of index. We will do count of index. So which will all always be the same thing, but here you can see that you know on which day we have which count of index or how many count of index. So for example, on 20th, most of the contacts are made. Considering maybe when year end will come, they will meet their targets, and then on 28 maybe some kind of follow up. Now in this particular chart, we only have one value, and that is x-axis count of axis. So this graph is showing us all data. Now here also we have to see what is its effect on our term deposit. So we will just use it in legend, and then you will get a simple chart here which will show you, for example, let's say on this day. So this is the 7th day. We contacted 16. We contacted total. There's a 1700 or 1800 people, out of which uh, around 157 said yes, and 1660 said no, or did not result into any type of campaign output. So this is count of index by day and term deposit. What I can do, I will just make it 1/3, and I will simply copy it one more time, and after copying it one more time, I will simply replace the day with month, because we also have the month here. So month May, June, July, etc. And so this is by month. Let's visualize this. So here you can see in the month of May, yes and no ratio in the month of July, etc. In case in last months, you can see obviously here number of no's are more, but in case of October or September or March, these ratios are very close to each other, right? So that's why we can say these are more. If we are considering this output, then month is a very important factor to consider, and so is count of index by day. Instead of count of index by day, we will simply call it term deposit by day, or whatever particular name you want to give it, and this is by month. I am just making all the heights equal to 200 in the first row so that we can put more visuals in the chart. Here also we can go and go to property, and what we can do, we can simply copy it one more time, and here we will bring duration, like on the basis of duration what is the effect. So you can see in these cases, like in case of yes, uh, when duration is around 254 seconds, okay, so in those cases most people have said yes. It is not necessary that when call is of longer duration, we have more yes than no's. But yes, this particular variable also has effect on our outcome. So here you can see that in a simple area chart, we can also use line chart, which is basically the same thing. So whatever you prefer. We also have a stacked area chart. In case of a stacked area chart, you just see them stacked on top of each other. So here also you can compare, and this also gives you a better indication of ratio of yeses and nos in that particular range. And this is by duration. And I will try to adjust them in the same width. So later I will adjust their width so that it is all of them have equal width. Make sure. As we created this chart, which was a stacked column chart, we will copy it because we have to see the effect on education. So here we have a education column. In education column, we have either unknown, primary, secondary, or this type of variables or values. So here we will simply remove contact from here and drag education. And this way we will be able to see education, while like people who have done secondary education have been contacted mostly, and that's why we can see the outcome of yes is 2450 in this group. In case of primary also you can see there is one more thing you can do on these type of charts. First of all, you can visualize them like for example, this is stacked column and this is stacked bar, so you can just use a different type of orientation for it also. Okay, gives a different kind of view here, so all of them are not looking same. And you can also adjust their colors a little bit, so you can go to the visual setting in bars, so like enable different type of transparency, or let's say for yes we want to select a color that is, in this case let's say it is green, or let's say a little lighter blue shade. So whatever you want to do, you can do it from here. Okay, and this is subscription rate by education. So yes, we are writing rate here. Before that, I would just want to show one more thing in visual. Our data labels are off. Okay, so our data labels are should be on here. That's only when you will be able to see it. And if you want to see yes versus no percentage, so you can simply change it into 100% stack chart, and that's when you will be able to see like in which case the rate is more. For example, in tertiary we have 15% yeses, right? In case of unknown, 13%. So this will also help you in finding out subscription rate by education, and you will be able to see the percentage actually. We are not able to see for yes because width is very less. When you will increase the width like this, then you will be able to see that. So obviously we always have the option to zoom it or highlight it. So that's why we are just keeping it here, so that anyone who is viewing the chart will be able to zoom and see the data. And there is a simple conclusion that we can tell is yes, in case of tertiary and secondary and unknown and primary, we can see a difference. So this is also causing some effect on the output. Now in the similar way, we will see it for housing. So here you just have to replace housing, and in case of housing we will use, this is 100% stacked bar, this is 100% stacked column, so we will use housing like this. And data labels are on, we will simply details, let's try to reduce So height is so low that we cannot see, so obviously then we can make it like this. So it's your choice, but in case here we can see, for example, with housing no, in that case term deposit yes is more, percentage of term deposit yes is more there, right? So this is subscription rate by education, and we will simply use the 100% column chart. So this ratio is at least visible here. And this is subscription rate by housing. So we will simply go to title, subscription rate by housing. All of the variables that we have compared with our outcome have some kind of effect on our output. Similarly, we will create one for job as well. So here you can see, uh, when you will see the column job, management technician, we have different type of people like admin, blue collar. So here we have a big set of people, so we will simply make it wider, and here instead of housing we will simply go to job. Okay, and in every set you will be able to see the percentage. For example, in case of retired, percentage is higher, and in case of a student also, percentage is around 28.68% with yes. Okay, so this is very important. What we will do simply is, on on x-axis I will just make the values bold and change their color so that we can see them properly, right? And if you want, you can disable the y-axis because we already know that they are in percentage, so we can disable. So this is a simple way. Obviously there is a lot more to analyze here. Okay, this is not it, and we'll try to just fit one more chart here. And because we have a few variables, we will create another chart with more variables, but let's try to adjust it as we have adjusted 4 charts above. Now here we also have marital status and loan. So example, if they have loan, yes or no, or what is about their marital status, right? So in that case, we will just get rid of job here and see in case of marital status. So married, single, and we also have divorce. So this is not obviously in case of single, deposit yes is 14.9, almost 15%. So we can see the difference. And in small multiples or tooltips, you can bring more details like known. Okay, so here when you will over any particular case here, so for example, let's say these who have said yes, they are single and their first loan is no, right? So you can see those type of insights here, and which is simply concluding that most of these variables have effect on our outcome. This is the first dashboard that we have created for this data set. We will simply save it. You can also use variables like p-outcome, number of contacts performed before the campaign, etc. to see the effect. Obviously, we can fit them, but we will do it in the second video that we will create for this. And obviously, while doing exploratory analysis, you can always find out which variables are helpful for you and which variables or fields do not have any type of effect on our outcome, so we can drop them while creating machine learning models. Okay, if you like this tutorial and would like to receive a notification when more videos like this are posted, so please subscribe to our channel and watch other videos in the playlist also. They will be helpful for you. And if you have any type of suggestion that you have in mind, like you want to see any type of analysis or chart, any question, you can post your questions in the comment section below. Thanks for watching once again and have a nice day.